Hello everybody, welcome to our channel once again. Today we have a more industry-focused discussion, and it's relevant if you are working in advertising, marketing, or in media kind of world. If you're in this sector, you know what audience segmentation is and how important it is. So today we're exploring how we can combine audience segmentation with AI agents on Databricks to simulate real audience reactions. So before we go into the topic, we are going to introduce Jack. So Jack, can you tell us a little bit about you and your role in Databricks?
Yes, of course. Thanks for having me. So I joined Databricks as a solutions architect back in September of last year. Before I joined Databricks, I came mainly from a data science and machine learning background and worked across a number of industries. At Databricks, I sit in our CME team, which stands for Communications, Media and Entertainment. But in particular, the customers I work with are in the media and advertising sector. So my role is to support my customers in evaluating Databricks as a platform, advising them on how to architect and build their data and AI solutions in Databricks. And the solution and the blog post that we're going to talk about today sits kind of at a nice intersection between my technical interests and this industry that you mentioned at the start that I'm working very closely with.
And what inspired you to write this blog post? What problem or gap were you trying to address with this blog?
Yeah, so firstly, I wanted to work on and I guess write about something that's relevant to my customers and to my industry. But actually, it was inspired through some of the conversations I was having. So in working with my customers in the advertising agencies, they talk a lot about segmentation. Segmentation is a key part of what they're doing for their clients. And it's well developed and established. Actually, the techniques haven't really changed in a long while. And segmentation is still quite a static thing. So essentially, they do some clustering, they build these and they hand over some persona descriptions or summary statistics. And then it kind of stops there, right? Like that's the end. And the creative teams and the marketers still don't really have a way to interact with these segments or test whether the messaging actually lands. And often they use things like focus groups, which is really valuable, but that's slow, it's expensive, it's quite difficult to scale. And then I actually read an article from the CTO of one of my customers who talked about this idea of what he described as a synthetic focus group to test and iterate on ideas faster. And you could probably find this article online somewhere. So I thought, well, what if we could build like a demo example of this focus group that uses the same technology that we're already using in Databricks? That's kind of what inspired the demo and the blog. And it felt like a good solution of structured machine learning, LLMs, and then also some real kind of marketing value that I could talk about and bring to my customers. And then I worked with another solutions architect, Marcelina, who helped me on the blog post and refining the solution.
Amazing, Zach. Thanks. So can you maybe share the blog post so we can go through the architecture of the solution a bit?
Firstly, you segment your customers using traditional clustering on structured data. So things like demographics and behavior data. Then you enrich those segments using unstructured data like paid reviews or something else. And then you can generate the personas using the large language models. And then the last part is you wrap that persona in an AI agent, which simulates how the segment would respond to some copy or an advertisement. And then the agent gives you feedback to that in real time. And all of this is running inside Databricks, from clustering, persona generation to serving the agent via MLflow and exposing it through a Databricks app on the front end. There's some other components here. So there's also kind of an optional part to leverage vector search as well to look at previous copy and ad campaign data if that is something that the agent can reference to improve the response. So that's the overall flow at a high level.
And I guess you can expand the solution by adding extra components, right? Hitting APIs, adding different vector search components and indexes. Yes. Okay, amazing.
And so you start with a traditional ML approach on the left-hand side when you do the clustering before you feed that into a Gen AI more approach on the right. Is that right?
Yeah, correct. So the structured data input feeds into clustering. So in this case, k-means. And then you get the enrichment from the unstructured data, the text data, where the LLM isn't just working off, say, age and income, but it's actually looking at previous reviews that the customer did. So you can get a sense of things like language and sentiment and what the customer is interested in and the kind of values and like motivations they have. And all of that data combined is being used to generate the persona. So that's where you're actually getting what you'd kind of get from traditional clustering in a sense, but you're getting a more detailed view, which I can take us through in a moment, which, is a large list of, okay, well, this is the segment, this is their persona, this is what they're interested in, this is what they've kind of talked about in previous reviews and things like that. And then all of that is being used to feed the agent, which is actually the interface that the end user is talking to.
Same. So can you show us, now you've talked about the architecture at a high level, can you show a little demo of what that looks like?
Yeah, absolutely. So to start off, I'm going to begin with the app.
Yes, excellent.
So can you see that? Yeah. So the app is a Streamlit application. It's quite a simple user interface. And what you begin with is a drop down, which is this view here of customer tribe. So what we've done is we've preloaded 5 different types of segments, and this is based off that clustering exercise. It's based on the data we have about audiences and like where they fall in terms of age group, demographics, and the kind of products that they buy and things like that. So,
sorry, Jack. So this is kind of coming from the first unsupervised exercise, the clustering you did.
Yes, exactly. Okay. So you've got. I'll show you the data set after, but you've got segments that are being driven mostly by the structured data and the unsupervised process, as you say. And then that's what gives you things like, okay, so you've got a suburban family oriented cluster, you've got high income college students, etc. So if we pick one of these clusters, we can start with, actually, I can ask the agents to say, just tell me about yourself, your demographics. So we can actually prompt the agent to give us a bit of information about itself before we start trying to give it a task to do or give it things ads to improve and stuff like that. So what this is telling you is for this cluster, this is typically a 30-year-old in that kind of range, and that's coming from the structured data that we that's being fed into the profile. Mostly kind of high or medium to high income. They have an active lifestyle. They're interested in tech trends and they're interested in like technology and the features. Are very active on social media platforms and things like that. And that information is being driven out of the data that we're feeding into the profile on what kind of what kind of products have they reviewed and what kind of areas have they shown interest in the past. So they might have bought things like smartwatches or laptops or something like that and left reviews and remarked on the technical features or the performance. So that's where this information is coming from. So we can ask that kind of question first to get a sense of, what does our profile look like? What does our segment look like?
Excellent. So it doesn't come from the knowledge of the LLM, basically. Is that what you're saying?
Yes.
That it comes from the clustering.
Coming from your data, yes.
Yeah, awesome.
But let's actually give a task, right? So ultimately what I'd want this solution to do is I want it to take some ad copy and start to refine it and to come up with some improvements. So I have some prompts that I've made before. So a prompt could be something like, let's take a generic piece of copy, like introducing a sleek new laptop with high-end specs and modern design. Can you improve this copy? Can you come up with something new or give me some ideas on how I can improve it? And that's what it's doing here. And here you can see it's given me some ideas for suggested improvement. It's made some changes that it thinks is relevant to the segment and relevant to the kind of audience persona that we're speaking to right now. And it's continuously going to ask me to refine and improve on this. So at first I might look at this copy and say, okay, well, maybe this is good, but it's too long, or it's not quite exactly what I'm looking for, or it's touching on things that aren't relevant to the product. So I can continue to refine this and so on. But when I actually go to show you the agent and the tracing, you'll see that this is leveraging some vector search to actually give like some inspiration for the copy that's been returned. It's not just sort of generating this purely from the foundation model.
Excellent. And now the foundational model is just an open source foundational model. No fine tuning has been done or anything, right?
No fine tuning at this point. And I think certainly, given this is quite a kind of simple demo to set up, it would probably be better to have fine tuning in the future. That's an improvement that we'd like to make. But right now, this is a foundation model. It's using Llama 3.3 in Databricks.
Amazing. Should we see a couple of other prompts just for the sake of the demo?
Yeah, sure. Actually, what I can do is let's change the segment. So if we do something like, let's do this one.
So now back to these segments then. So these segments are pre-created and they are fed in the prompt kind?
Yeah, so actually what I'll do is just to kind of make it clearer and show you more the end-to-end. I'll come out the app because the app is just the front end and it's easier to see what's going on if I go into the playground and the tracings. Firstly, you can see the app that I've deployed here. This is linked to a model serving endpoint. So we're all hosted and managed in Databricks. If I go to use and try and playground, what I can do is show you how the personas are being fed into the agent and how the responses are being generated and so on. So if I take that example from before, which is the tech savvy professional, what it's actually using to kind of choose between the different personas is the custom inputs. So if I unlock the custom inputs and then just enter what we call a tribe, so I'm using the same persona as I chose in the app, which is the tech savvy professional. And then I'll start with the same kind of generic question, like, tell me about yourself. Then what it will do is it will give me the response similar to before, but now I can actually go and look at the trace. So I can see, for example, this is a LangGraph framework. I can see the agent, steps that it's running the function. So this is like quite simple, right? There's no tools being used. There's nothing here, but you can see the inputs and outputs. And as part of the input, you can also see the profile that's being preloaded, which is being driven from the custom input. So this.
Yes. Can you explain a little bit the custom inputs? Because I don't think we have introduced it at all in any video so far.
Okay, yeah, sure. So essentially, custom input is basically a parameterized way of feeding information into your agent at runtime. So when you're running like the predict or you're invoking the agent, you might want to change the prompt somehow. So in this case, the one part of the prompt is the profile, and that's really the key part of the prompt because it's actually giving the information to the LLM about how do I want you to speak, what's your persona, what are you interested in. It's all of that information is being driven by the profile, but we have 5 different profiles to choose from because we have 5 different segments. So in that case, we need to be able to change that. So in this case, I've just changed it in the custom input in the UI, but in the app, it's part of the application code. So when you flip between the drop down, you change the custom inputs.
So like it's a parameterized way to change your prompts depending the request you receive.
Exactly. Yeah.
Nice. And now what profile or prompt you're going to pass, everything depends on the drop down, for example, in the app, right?
Yes.
Okay.
Yes, exactly.
And can you show us the data and,
Yeah, no problem. Before I do that, I would like to show you the example of the vector search, because then that will kind of go back to explain the whole flow, make things a little bit easier to see. So if I use the same prompt as before, which is the one where I've asked it to improve some ad copy, what it will then do, you'll see, is it'll reference a source. So the source here is actually some like previous ad copy that it can use kind of as an inspiration to generate new copy, and it's not just coming up with it completely from scratch. And again, you can see this in the trace, so it's a little bit more detail now. It's actually leveraging a tool, which is the ad copy retriever. And the ad copy retriever is utilizing vector search to pull the most relevant previous ad copy that's linked to what you're asking the agent to improve. So I thought I'd just show you that first, because this is one kind of key part of the solution, is being able to switch not only between the different personas and profiles, but also being able to leverage, in this case, just a single tool, but it's kind of something that's very extensible, right? So we want to show the capability to use tools as part of the solution. But also what I've mentioned in the blog is right now, this is just one tool, which is leveraging vector search, but it could be a tool that's using Search API, for example, to look for latest trends, or most recent kind of information out on the internet, which you might want to use as part of your ad campaign. So
Yeah, for example, could be for this specific segment, what previous copies had brought most engagement or things like that, right? So you can increase it as much as you want. Okay,
exactly.
amazing.
Yeah. There's a lot of ways you could go with this. So yeah, let's go into the code, and I will show you 3 notebooks that really kind of explain what's going on behind the scenes. So the first one is audience segmentation. So audience segmentation is the part that is doing the clustering and generating the personas. So let's scroll down. So you got step 1, which is building a clustering model from your demographic data. So here we've got a single table with demographic information. So age, income, education, like dependence, relationship status, that kind of thing. You take that information and you feed it into a clustering algorithm. If you've come from a data science background, this is all going to be very familiar to you. So k-means, you do some pre-processing steps to transform the data. You run k-means over a range of k values here. You fit your k-means clustering, and then you generate what's called an elbow plot, which gives you a sense of this that you should choose ideally. This is all pretty simple, kind of using sklearn. The only difference, I guess, from a Databricks perspective is that you're wrapping this all in MLflow. So you can track the experimentation, you can log your metrics, you can log your elbow plot. And just, as if you were developing this really, you would be kind of iterating on a number of different types of parameters, and perhaps like looking at different features that you could include in your clustering and so on. So once you've got that, you have an optimal K for your k-means. You log a final model with your final parameters and any other kind of information that you want to record. In this case, we recorded a silhouette score, which is a measure of how well the clustering is performing. And then you've got your labels and your clusters defined at the end. So this is the part where we generate tribes. All we're really doing here is we are basically just giving the clusters some nice names.
I'm keen to understand a little bit, how did you end up defining these clusters in that way?
Yeah, so it's really just some analysis to understand like aggregates and things like that. So firstly, we have our cluster labels, and then you'll look at, okay, we found some nice clusters which separate by median age, by income, locations, relationship status, that kind of thing. Now, this is all using a synthetic data set, which I generated myself. So, the data splits quite nicely.
Yeah.
In reality, data is quite messy, and it's not always k-means isn't always going to work quite as well as this. But in this case, you can see that this has kind of been set up to work in a nice way. So you'll have things like, okay, well, here's an older group with a high income, lives in certain areas and so on. But there's really different ways you could do this. Like ultimately, the idea is just to be able to pull out the metrics and the key aggregates from your data set to determine how you want to define your clusters. And actually, this part is pretty much clustering in marketing teams and stuff like that, right? So they'll run some clustering, they'll get outputs at the end, and they'll try to interpret those clusters. Yeah. It will be very kind of just inspect visually and then decide, okay, well, this is my young hip professional cluster, and this is my old cluster, and so on.
Yeah, I want to see if you actually sent it to an LLM to interpret, or you did it in a more statistical way.
No, not in this case. But you know what? That's actually a good idea for maybe future exploration of this. Is you could just take the outputs and feed them into an LLM and see what it comes back with. Mm. But no, in this case, it's a very simple approach. Yeah. So once you've got your clusters, we've just given them some names. We use this terminology, which is kind of an industry terminology of tribes. So the idea of we like to sort of give things interesting names and then a kind of a description of, okay, like the innovators, but what does that mean? So this is like your tech savvy professional and speaks to the demographics. Once you have that information, we're then using the outputs to generate the customer profiles. So I've brought in the unstructured data, which is like the reviews. So here for well, not all users, but for many of the users, we've generated some reviews from previous products and things that they've kind of used before. So we can give that as context to the LLM to generate the profile. We join all of that together. And then we have this prompt here. And this prompt is the key to creating like a consistent profile definition, right? There's a lot of, prompt engineering here, but ultimately what we want as an output is something that's quite structured. So we want the persona name. We want to understand from looking at the unstructured data and looking at the demographic information. So can you describe this tribe? Can you talk about their interests, their preferences, anything they've complained about before? What's their communication style? Like that kind of issue, because this is all going to be super relevant to determining like the agent's behavior in the end.
So then after you build the clusters and you try to explain them a bit, you augment them with this kind of extra review data set. And that then goes in and creates the persona that you pass into the app.
Yes,
Got
exactly.
Okay.
Exactly. So yeah, you do that, you feed it into your foundation model. As I mentioned before, in this case, it's Llama 3.3. And then you iterate through the 5 different segments and you generate the profile. And then we just save that profile down to a volume. So that's all that's happening in this notebook. If I go into the Unity catalog view and I go to volumes and then profiles, I can show you that final JSON output and you can see what these profiles look like. It's not very well structured, but you can kind of get a sense here. The persona name, the overview of the persona, their values, etc. So this is the information that will be fed into the agent to get your responses.
To understand, so you did the clustering. So then you have your 5 clusters, you decide on the name. And then how did you generate the profile again?
Yeah, so if I go back to my notebook, so there's a prompt. There's a function here, which is essentially a wrapper for the prompt. And as you can see, you've got demographic information. So all that information that we pulled out from like the aggregates from the clustering. So like average age, average income, typical like dependents and occupations and that stuff. And then we've also got some like sample of the paid reviews for the users in those clusters. So if you take we found a cluster of say college students, and college students, we summarize the information about those college students. So like their age and income, we feed that into the prompt. We also feed in a sample of some of the reviews that they've left about products that they've purchased in the past. And we use all of that information as part of this prompt template to generate the final profile.
So the reviews are key to generate the profile in the end, right?
Yeah, the reviews and demographic information, but the reviews are the information that talk more to like how does the audience actually speak and what do they care about? Because if you go into the reviews, you'll see things like, oh, they reviewed this product and they were really angry about this feature, or they were really impressed by this price point or this kind of like aspect of the product or whatever. So those are the things that are going to be really guiding how the agent responds to you, because what we want to understand is what does this customer care about, and it will look at previous reviews from similar customers in that segment to try and guide that behavior.
Got it. So it's clustering, and then you have the reviews based on those clusters. You can see the reviews for each group, and then when you take all this information, demographics and the reviews, you generate this profile for each tribe. Got it.
Exactly.
Thanks.
So if there's no more questions on this section, I can show you the vector search. So the idea behind the vector search was to, I guess, not have the response from the agent being too freeform, if you like. So even though we have this information from the profiles and from the audience, if I say, oh, well, go and generate some ad copy about, I don't know, TVs or shoes or something like that, it can kind of go in any direction. And when I speak to my customers, they really want to kind of root this in terms of like their client's tone of voice and how they run campaigns and the previous creatives they might have used. And they have all this data, right? They have
It has
the
to be a
data.
bit consistent, right?
Yeah, exactly. And they have data on how the previous campaigns that have worked well. So if your client is, Coca-Cola, they've run millions and millions of campaigns over the years, and they know which ones have worked well, which ones haven't worked as well. So you can sort of use some of that information to guide how the agent should respond. So this step is really short, but essentially you just create a vector search endpoint. And then what we do is as an index, we're feeding this table called campaigns performance. Let me just show you that table so it's clear what's going into this. So campaign performance is really just a view of previous campaigns. You have a campaign ID. You've got ad copy, which have used in the past, and then you've got like data on impressions and click-through rates, things like that. So you can use that information to sort of like guide the responses. And then you bring that vector search index online, and then I've just tested it with a simple query. So in this case, it's using the similarity search. Fitness and exercise was my search term, and then it comes back with the most relevant previous like ad copy. So you've got a couple of campaigns related to smartwatches and things like that. So yeah, that's all the vector search is doing, but we're going to use that as a tool for the next step, basically. And we can also apply filtering and things like that, so we can link it to the relevant tribes and things and so on. So yeah, so that's the vector search part. It's quite a short step, and then it's really kind of just fed into the last notebook, which is the agent notebook.
And then in the vector search part, the fact that we have all the impression results, click-through rate, and etc., it's not actually being used at this point, right? So you may fetch the metadata, but is it, when it is passed to the agent, does the agent have any logic to say, I don't know, these are the 4 results returned, but use mainly the one will have the best impression or the most click-through, the highest click-through rate?
No, so yeah, it's not being used at this point, but my idea in the future would be that you can either like filter or you can sort or something like that. Like you can have some kind of additional logic to say, take away, the campaign that doesn't work so well. But my narrative, I guess, behind this table right now is that these are all of the campaigns. Like the campaigns already been pre-sorted, and it shows the campaigns that have worked well for the different segments.
Yes, or you could re-rank them based on these. You could do many different things. You can expand a lot this example. Yeah, very nice. Cool. Yeah.
So the last notebook is the actual agents itself. So you've got a first step, which is just to define the agent and create the code. So this is a bit of a long kind of step, but I'll explain through it. So you've got the initial prompt template, and this has 3 import variables. So it's got the tribe, it has the profile itself, so all of that text that we saw from the step 2, and then it has the retrieved ads if it's using the vector search output. We've given it some guidance. So what we want is you to tailor copy specific to your persona, assist the user in doing this by acting as this tribe, testing ideas, tailoring the ad content. We have to give some guardrails, of course, around, keep this information. Don't give yourself like a gender or ethnicity, don't make stuff up, keep it on point, like don't redirect, make sure you redirect the conversation if you're asked something that isn't relevant to generating ad copy and providing feedback on a campaign. So yeah, things like that, big part of this. It just helps to make sure that the agent is like staying in character always. This is the tool. So we're using the vector search retriever tool to actually basically create a tool that the agent can use from the previous step. So you can see here that we've got the campaign ID, the ad copy itself, and this is the index name that we just defined in the previous notebook. And then you've got all of the agent logic. So you have a step for generating the prompt, a kind of decision point about whether retrieving past ad copy is useful. And you saw that earlier in the agent trace, right? So if you ask a general question around, just tell me about yourself, or what do you think about products or whatever, the agent can make a decision about whether retrieving this past ad copy is useful. If it thinks it's not useful, then it will just carry on and it won't use the tool. If it thinks it's useful, then it will leverage the vector search tool and give you some ad copy that you can use to guide the final output. So that all of that kind of binary logic is defined here. And then you format the prompt, and then you just call the model, you run the LangGraph agent, and then you've got your final predict method, which is what we're using when we invoke it from the app. That's basically it. A lot of this is kind of like templated and stuff from the docs and the existing kind of demos and stuff that we have out on Databricks. So there's not too many changes here. But once you have all of that, you can define, you've got your agent, you can test it in your notebook. You can actually test some of these prompts that I was showing you earlier, and you can see where the custom inputs is being fed in. And you can look at the trace. So that's all really easy to do in MLflow, like to see how your agent is working, making sure that it's using the tools correctly, making sure that it's doing all the things you expect it to do before you deploy it to like an endpoint. And then the last step is to log the agent in an MLflow model. As I was building this, you've got various kind of iterations and you test different prompts and stuff. So it's really important to be able to track all of that, to be able to register different versions of your model before you deploy it and before you make kind of any future changes. A few things to be aware of are making sure your serving endpoint can leverage resources. So in this case, like the vector search index, it needs to make sure you have permissions to be able to call that, the serving endpoint as well. And yeah, that's basically it. And then the last step here is just deployment, which goes back to the start where we were showing you the serving endpoint.
Thank you, Jack. Amazing. And so as you were building this, did you find any technical challenges, anything that you want to share?
Yeah. So there was a few. So actually, probably the biggest was generating good data to use for the demo. So these don't really exist in the public domain, but I know my customers have these kind of data sets. So I had to use LLMs in the first instance to create like synthetic data, which allowed me to demonstrate the solution in a clean way. But in terms of the actual solution, so, hopefully people shouldn't really care about the data itself, because the idea is you can plug and play with different data sets. But the biggest one was getting the LLM to try to behave like the persona consistently. So you need to be careful in terms of how you manage the prompts, how you inject the profile at runtime, and like setting those boundaries that I just mentioned so it doesn't go off and do different things. And that's what we solve with the like templated system prompts in LangGraph. The other challenge was retrieval. So if you're using vector search to surface like the relevant examples, you need the agent to decide when that's actually useful. So that's why it took me a bit of time to build in that simple logic step to ask the LLM if the retrieval is warranted, and if not, it skips it. And actually the last part was just creating the app, and this was more just because of experience, because even though Streamlit is a pretty simple framework, I didn't have a lot of experience with creating a user interface, so that took a bit of time. And I actually haven't showed you the app code yet, but you can see all of that in here. So as I said, Streamlit is really, really simple to use. This actually isn't a lot of code at all to create a simple UI. And this is the main part where the serving endpoint gets invoked. But
I hope with vibe coding that is going to be easier for us.
Yeah, I may have had a bit of help with the Streamlit. But yeah, it's a very simple way to like be able to show something to someone without having to just show them a bunch of notebooks and Databricks Workspace. I can just go back to the app and I can show very simple drop downs and prompts and responses without too much distraction, which is really nice.
It's beautiful to not scare business users.
Exactly, yes.
O3 all the way to do vibe coding for front end purposes. I've done that like quite a lot. And also for generating synthetic data, this is amazing. You can just do that in ChatGPT and get like some really, really high quality fake data. So I really recommend.
Yeah, definitely. And I had a lot of help from ChatGPT on a lot of especially the Streamlit coding.
Amazing. Thank you, Jack.
Oh, thank you.